work. I work for Entity Data Italy, and since a few years I'm working on metrics and basically on IFPAG and SNAP methodologies. In today's speech, I will talk about the evolution of application architecture in later years and how they influenced boundary or how can we handle this evolution in boundary and BFC granularity identification. We will see some example of applying of application of FPA or IFPAG on service-oriented architectures, on microservice architectures, and some counting examples in the cloud with some final consideration about that. In later years, software architectures have basically evolved from a monolithic approach where all logical and functional levels were in the same object to service-oriented architectures where business services or any application layer service could be developed with the service paradigm through web service, MI, or any other technical solution, to the final microservice, which is the latest architecture which has been designed, where any service, any group of operations which are collected within a service is a deploying object which can be deployed in an independent way. This architecture framework is particularly fit for cloud environments where any system is virtual, and also virtualization of buckets of Dockers can be very useful when scaling application depending on traffic needs. Quickly, let's recall something from theory and definitions. So when measuring application, two critical activities are boundary definition and granularity of base functional size components. When you define a boundary, if you define a loose boundary, you lose correctness when measuring software complexity and value. And therefore, we usually, when measuring an application, we usually speak about software complexity. But often measures are used also to value software contracts. So if you miss the complexity, you also miss the value of your work. On the other side, too many boundaries may increase the function point count, basically because of multiple counting of data functions. And this undermines measurement precision, just like a loose boundary. So it's very important to define, agreed with the customer, a correct set of boundaries. And the functional architecture has become more and more important when handling software contracts. The other big question is granularity of base components, of base functional size components. There is a historical issue on data function, where functional modeling should settle between the detail level of DB tables and the abstraction level of business entities. An example is that relational extension table are usually REDs of some ELF, but also when you consider a business entity, just like a customer, you have to, in order to correct model the business entity, you often have to group tables. So you may have the anagraphical view, the fiscal view, the payment view of the customers. And they should be modeled as rats of the same ILF, of the same complex ILF. And this changes function point numbers a lot. The another question about identification of transaction functions. Obviously, the theory is that the transaction function is the smallest unit of activity that are meaningful to the users. They must be autonomous and leave the system in a consistent state. A web service natively matches this definition, but the meaningful to the user is the key aspect. Through the primary intent, we may identify if they are external input, external query, and external object. But the meaning of the service functionality, the service provided functionality to the users is the key aspect to identify it as a single elementary process or as a step of a more complex EP. The classical examples are the different steps of a workflow, which may be portion of a single elementary process. That is, you can see the workflow as a single elementary process, or maybe different elementary processes, whether the customer has a view of the intermediate state. So when we apply these principles to measuring of contemporary architectures, we have to identify a measurement approach which should take in account the higher development costs than that complex architectures require. But we have to be careful not losing logical correctness of functional measurement. We cannot count badly. And so the basic principles are always the same. Define boundaries which currently represent business needs and user view, and identifying elementary process with a granularity coherent with business needs. So let's recall briefly what is a boundary in function point analysis. A boundary is an application boundary which defines what is external to the applications, indicates the border between the software being measured and the user, and acts as membranes through which data processed by the application travels in and out. The key aspects are that it is dependent on the user external business view of the application, and it is independent of technical or implementation consideration. The boundary is determined based on the user's view. Therefore, boundaries are always to be agreed with the customer. From a theoretical point of view, if we consider an application as a set of business functions, this set of business functions could be provided with a monolithic architecture, a service-oriented architecture, or a microservice architecture without any change to business functions. Therefore, we could, from the theoretical point of view, say that evolution of the architecture could be a technical aspect, and we should not have any change when passing from monolithic to microservice architecture. But there is a but. In parallel with the evolution of architectures, also user requirements have changed and have evolved. Architectural and technological aspects have become part of bids and contracts. Users, when require a new application for their information system, often within the contract asks for a specific architecture or a specific technical solution. For instance, if they plan to deploy their application in the cloud, they usually require in the bid that the solution should be microservice oriented. Maybe without defining the technical framework for microservice, but they require a microservice architecture. Therefore, there is a change in the level of acknowledgement of application function and in the user view of the application. That is, that the architectural solution has become part of the requirements. Therefore, there is a change when in this there is a change in the function point, in the functional modeling, and in the function point counts when passing from monolithic to microservice. We will be some example. Typical situation, we start with service-oriented architecture, which is the first step. Typical situation can be separation of presentation and backend. For instance, a multi-channel support with multi-supplier, with different supplier, different providers for front-end application, and backend environment with heterogeneous technologies and maybe different providers. Therefore, boundaries must be redefined with advantages for both actors, both the customer and the providers. And even measurement granularity can change. Let's see an example. Here we have a simple example of two disposal functions sharing user status check. If we measure with a monolithic approach, with a monolithic development approach, we have service 1 activation with user status query inside, service 2 activation with user status query inside, and we simply count two external input to elementary process for a total of 8 function points. With a service-oriented approach, we obviously define a user status query service, which is called by the 2 service activation services. Therefore, we have 3 elementary processes for a total of 12 function points. In this way, we see that with a service-oriented approach, when the user has visibility and recognize use and utility of shared services, we have an increase in function point counts. As for boundaries, when measuring a service-oriented architecture, an accurate and correct definition of boundaries is basic. That is, it is important the methodology. That is, we cannot ignore existence of a backend environment and of a front-end environment when organic to business needs. In Italy, at least, it's quite common to have which are set depending on cost centers of the customer. This means that with this often we lose obviously definition of accuracy of the measures. Otherwise, the design should be fit to the business view. Nowadays, for a web application, the 3-tier implementation is a technical solution which is quite common, and it is not enough to define a boundary between presentation and business logic. So we have a great importance, a great attention should be put in defining a functional architecture agreed with the customer, which is the basis, which should be the basis for counting of development. Just a second, please. Really sorry, but I live in a quite noised zone, and I did not notice before starting to speak. Let's pass to microservice architecture. The basic characteristic of a microservice architecture are that any component service within a microservice architecture should be independent, must be developed, deployed without influence of other component services. The various services should not share any code or implementation, and persistence data for a microservice should be private and segregated within the microservice. Any communication between microservices should occur through well-defined APIs. This is the theory, of course. We will see that this is not always the case. When migration from SOA architecture to microservice architecture, some new elementary processes may be identified because some operation is maybe evidenced within the architecture. But anyway, data functions should be segregated and associated to microservices. Therefore, let's see an example. A microservice example. If we measure a microservice example with the SOA approach and the single boundary measurement, in the architecture we will have a microservice for disposal actions and a microservice for user status user status services. Therefore, the user status query services is an operation of these microservices, and the two activation functions are operation of the disposal actions microservice. With this approach, we have the same count we have seen before for SOA, and we have the 3 elementary process for a total of 12 function points. If we consider each microservice, each deploy object as a boundary, which it might be an approach in microservice architecture, we see that elementary process identification is the same. We do not have, when communicating between between the two microservices, we have that the elementary process identification is the same, and we have a total of 12 function points. The things changes a little if we consider sharing data shared. If we have sharing of some data which are accessed from the services. If we have a single boundary and the sharing of customer ELF between microservices, we count only an ELF in the count, so we have a total of 19 function points. When we pass, if we consider a microservice boundary and we set the customer as an ELF of the user status microservice, we have some more function points which come from the external interface file for the disposal action microservice. So we see that if we do not have a strong data segregation, we may have an increase of function point counts when considering a microservice boundary. The key principles for microservice design are single purpose, loose coupling, and high-level cohesion. That is, each service should contain all related behaviors and data. So when considering data segregation, whether data segregation is applied to a microservice architecture, there should be, from the logical point of view, the straightaway solution should be define a boundary for each microservice. But we can see that this could be dangerous because, and we will see it later. Just recall a quick recall before going to example about application component test in cloud environment. I took this slide from a Woodward presentation from cloud perspective. Let's recall that the three main cloud service models are IaaS, PaaS, and SaaS, meaning infrastructure as a platform as a service, platform as a service, and software as a service. You buy in the cloud just the hardware and the framework or development environment software, or a complete software service which can be customized. FPA can be used to measure software complexity in any of these models, like as several studies have already shown. The key aspect is defining correct cost models which can be applied to function point measures. So let's see some examples. I analyzed a complete, a clean platform as a service solution. That is development of a full application on a platform in cloud, and two other developments which were mixed PaaS and SaaS solutions. This example, that is with a clean PaaS development. We have the application context is an informative and dispositive app developed on Heroku, based on consisting in 45 operations grouped in 10 microservices, and for interaction with legacy systems there were 24 external interfaces. This is the distribution of operation on microservice, and we see some example of microservice with their authentication, billing services, dispositive services, profiling services, and some support services for application operation. These two tables summarize counting. Here we have the BFCs which have been identified in the application. This is the counting applying a single boundary, and we see that we have the 41 elementary process and 41 operation distributed between external input, external query, and external output. Then we have 20 ELFs, which represent the data managed by the application, and 24 external interface file, which model the calls to legacy systems. When passing through the multiple boundary, the microservice boundary measurement, we see a change. We can note two things. The operations obviously remain the same, and so the transactional functions do not change passing from one boundary approach to the other. We have a slight increase in ILFs, with two of them which are shared between different services. We see a significant increase in external interface files for data entities, data functions, which are shared between different microservices. ELFs for one microservices which are accessed as external interface file from other microservices. This is the key problem when going to microservice boundary, and this applies when data segregation cannot be maintained in the technical solution. Summarizing the counting, we have that with single boundary, with the single boundary, the function point from the elementary process remain unchanged. There is a significant change in function point from data, which there is almost a 50% increment, which leads to a global 30% increment in counting. A 30% increment in counting should be, it seems too much to model the increased complexity of a microservice solution with respect to a monolithic approach. So we know that the single boundary usually does not model correctly software complexity. In this case, we see that also microservice boundaries can lead to incorrect, to wrong measures for application complexity. Therefore, the solution should be grouping microservices in congruent service contexts driven by data, driven by domain knowledge, obviously, and consideration about data sharing. That is, microservice sharing data structure, data object should be grouped within a boundary. And this functional architecture must be agreed with the customer, of course. Let's see another example about mixed PaaS and SaaS context. The first example is a ServiceNow Suite in an HR application with an interface with legacy system, and it covered a redefinition of 3 internal workflows in terms of user stories. Software impacts were modification of native steps, adding interface with legacy systems, definition of some new specific workflow steps, and definition of new data structure, and modification of existing ones. Therefore, this was a real evolutionary maintenance. There was a real evolution of an application with some development activities on which added and modified application functionalities. Therefore, it was quite easy to apply FPA, which showed correct both for measuring complexity and value and effort for application development. Another example is always with ServiceNow Suite in an IT operational context. The scope was customization of a trouble ticketing system. In this case, software impacts were just adding a new dimension for tickets context and a lot of configuration of suite functionalities. From the sizing point of view, this was a challenge because there were almost no functional impact, just one ILF and some changes to some web forms. And most activities were in data loading, product configuration, and graphics adaptation. Therefore, all non-functional aspects, which were estimated and valued and paid in man days, but it emerged a need for non-functional sizing, and maybe Snap. We are not using Snap, but it could be an idea. Let's see some final consideration about measuring in the cloud. Obviously, we have keep in mind to apply methodology, the FPA methodology when define purpose and scope, the definition, and as boundaries are a key aspect. A good practice should be to define a functional architecture with boundaries and maybe snap partitions agreed with the customer. Then obviously pricing rates have to be defined. It should be agreed when which value assigned to a developed function point to a customized function point or to a configuration activity. Some tips for boundary definition can be that obviously that with the microservice approach, with the microservice architecture, elementary process identification is quite simple because any operation is an elementary process. When counting a data function, an average solution between single boundary and microservice boundary must be agreed, because none of the two are the best one for measurement of a cloud application. The idea is to group, the ideal solution is to group microservice based on data sharing. And this require technical knowledge of the solution, domain knowledge of the solution, and discussion with the customer. When measuring, there should be a grouping of business function with depending on the need. That is, there should be grouped a business function to be developed, to be configured, and to be customized. These two, developed and customized business function, can be measured with function points, but cost values for developed function points and customized function point could change. Configured business function should be could be measured with some non-functional measurement approach like Snap. But Snap is still young and needs work, so it can be, there are some Italian customers which prototype this methodology. We are very happy about that, but it is still an adventure. Anyway, the modeling and measuring the non-functional aspects of an application is becoming more and more important in modern developments. FPA seems to be the only methodology valid in all cloud service model, and but there is a wide variability in pricing rates, because at least here in Italy there are still too few experiences in this. So I could end with the same slide that Paula used. That is, keep it simple, keep it clear with your customer, and keep in mind methodology and theoretical approach when measuring software in the cloud. That's all said.
Thanks, Marcello. That was great. All right, we'll have a look at the questions. What happens with data functions in the SOA approach? I'm not sure if you can see them in front of you. In one boundary, the data is an ILF, and in the same data, an EIF in the other boundary. Does that make sense to you? Can you see the questions, Marcello?
I think Marcello took up that in his presentation, right?
Oh, was that early? Okay. Next question from Carlos. Is software architecture influences, if software architecture influences functional measurement, then it makes it more difficult to compare productivity regardless of the architecture.
If software architecture influences functional methods, then it makes more difficult to compare productivity regardless of the architecture. Well, productivity and cost value assignment is a basic aspect when using function pointing contracts. Yes, I have no real evidence about this. Maybe ISBSG statistics could help. Anyway, I expect that if we in a monolithic application, Java application, we could consider a 2.2 function point per day productivity. I expect that in a microservice solution, we should go down to 1.5 or something like that. Yes, the answer is that I expect that when changing software architectures, you may have impacts on software productivity yeah, you may have impacts on productivity measures, ways to apply.
Okay. All right. From Carlos, to measure services bound only to internal applications, use as a function does not promote to measure design instead of functional user requirements.
I have to read because I didn't. To
measure services bound.
Well, this is a matter of what you consider user requirements. It's a question I evidenced in this when I introduced the architectural requirements in bids and contracts. Yes, this could lead to a change in the practice of function point analysis. Function point analysis has been designed to be independent from design and technical aspects. And this, of course, applied in 80s, in 90s, in late 19th century years. Now we have a different market situation. We have customers which are more confident with technical aspects. They know about technical architectures. They know that a service-oriented architecture may bring savings in maintenance and may increase the use of software and require less developments. They know that in the cloud you need the microservice applications, microservice architectures to save when scaling. Because you can scale the single microservice, you can replicate the single microservice depending on traffic needs. Therefore, with saves in fees, in software rates, and so on. Therefore, this brings in counting needs some knowledge about design and about technical aspects. That is, function point counting is, in my opinion, is no more independent from technical aspects. To measure correctly a complex complex software application, you may need to have some technical knowledge of self-design knowledge of the solution.
Okay. We're actually encroaching on our break time, but we'll just give this last question in, and then we'll have a shorter break. From Lusa, did you test other standard measurement methods such as Cosmic for microservices? And if so, did you find better results in terms of granularity, measurement scale, applicability, or the like?
Well, a try measurement with Cosmic is one of the homeworks that I did not manage to do during my holidays. So it's the next step of this exercise. My feel is that being concentrated on data transactions, there should be less difference with Cosmic, but it's just a feeling without any real consideration about this. As for the second questions, well, the guidelines should be grouping services and defining boundaries based on data sharing. That is, the basic guideline is, and this is the main reason for the technical and design knowledge when measuring a microservice application. Because you should know how what application function do and how they share business data in order to build a correct functional architecture with correct boundaries for a correct function point measure. This is an additional difficulty which is added to measuring complex architectures.